Hello. All right. Second day of trimester 2. Today is like a little bit of a new kind of concept, a little bit of a sort of review. It shouldn't be too bad. All right, so let's just dive right in. Today we're talking about solutions to a linear equation. So how do you know what a solution is to this line? How do you tell if this point is a solution? So the first thing I want to talk about is a flashback way back. I believe this was in the very first unit. We talked about what is a solution to this equation. And I asked you, is x equals 6 a solution? And we said no, because if we, let me get my pencil here, if we plugged in 6, that got 18 and not 15. So we said that this was not a solution because 18 does not equal 15. So solutions are numbers for variables that make them true. So the solution to an equation makes the statement true. So if we had said, does x equal 3? If you plug that in, you get 15 equals 15. That there is a true statement. So we would say 3 is a solution. So again, a solution makes it true. Now, what if we have more than one variable? And I want to know, is this not just one number, but is this ordered pair, is this point a solution to my line? Okay, so here we have a linear equation, which means if we graphed it, it would make a line. And I want to know if this is a solution. So similarly, like we did above, how we plugged that 6 in for x, we're going to take this ordered pair and we're going to plug it into our solution. So I want to know, is 3, 8 a solution to this? So this is my x value. This is my y value. I'm going to plug the y in where y goes. So 8 goes here. And I'm going to plug the x in where x goes, right next to that 2. So now when I rewrite this, we get 8 because y equals, and then 2x, which is 3, and then we have plus 2 on the end. So we just plugged in the x value for x, the y value for y, and now we're going to just see if this equals each other. So 2 times 3 is 6, plus 2, 8 equals 6 plus 2 is 8. So 8 does equal 8. That is a true statement. So we can then say 3, 8 is a solution. Okay, now I have this graph here because I want to show you what that means. So yes, the solution makes it true, but this is the purpose of us when we graph. So if we were to go ahead and graph this, so my y-intercept is 2, so we have a point here at 2. My slope is 2 over 1, so that means I go up 2 over 1. And then we graph that line. I'm going to just keep making points here to make it a little bit clearer. Oh my goodness, that was a bad line. And then we graph that line. Okay, so there's my line. Now let's look for this point 3, 8. So if we find 3, 8, 3 up to 8, you'll notice that that is a point on my graph. So a solution makes the equation true, and it also is a point on our line. A line, when we graph it, what that is showing us is this line shows us all of the possible solutions. So 0, 2 is a solution. If you were to plug that in, you would get something that's true. If you plugged in 1, 4 in, again, you would get something that's true. all of these points represented on this line show all possible solutions for this equation. That is the point of our graph, to show all solutions. But again, to check whether it's a solution, we simply just plug it into the equation. If it's a true statement, yes, it's a solution. And then I just want you to know that that means that is a point on that graph. That point, that ordered pair would fall on that line. Okay, so again, if an ordered pair is a solution to an equation, that means that that point falls on the line if you were to graph it. Every point on your graph represents solutions to equations. So now I have another example here, and you might be able to guess this one is an example of a solution. So this one is an example of a non-solution. So same thing, I want to know, is the ordered pair 6, 2 a solution to the linear equation y equals 3x plus 2? So I want to know if this point falls on this line. Does this point make this equation true? So just like above, I'm going to plug in the x where my x goes, and I'm going to plug in the y value where my y goes. So we start with y, which is 2, equals 3 times x is 6 plus 2. 2 equals 3 times 6 is 18 plus 2. 2. Oh my goodness, come on. Sorry. Oh my, I don't know why it's not working. There we go. I'm just going to have to use my mouse. 2 equals, and then 18 plus 2 is 20. So clearly 2 does not equal 20, so that is a no-go. So we would say 6, 2 is not a solution, because we got something that is not true. Now, again, if it's a solution, it falls on the line, right? My line represents all solutions. So if it's not a solution, it would fall not on my line. So if we graph this, you will be able to see that. So my y-intercept is 2. My slope is 3, so that means up 3 over 1. 2, 3 over 1. I'm going to keep going, up 3 over 1. All right, there is my lovely line. Okay, now if we look, we already did the math and said that this is not a solution. If we graph it, 6, 2 gives us a point right here. And clearly, that is way far away from my line. So here's like a visual representation of why the 6, 2 is not a solution. 6, 2 does not represent a point on this graph. So therefore, if we plug it into our equation, we get something that is not true, because that's not a solution. Okay, so again, these graphs are just kind of my visual way of showing you what it means to be a solution and not a solution. So again, solution means your point falls on the graph. Not a solution means it falls not on your graph. So steps for determining if it's a solution, you need to substitute your x and y values into your equation. You want to evaluate and see if both sides are equal. If so, it is a solution, just like this first one up here where we got 8 equals 8. If not, it is not a solution. All right, I want you to go ahead and pause me and try this one out. So again, you're going to plug in your 0.45 into your equation and then tell me whether yes, it's a solution, or no, 45 is not a solution. Your work should look like this and like this. So plug the x in where x goes, the y in where y goes. Tell me yes or no. I should very clearly see yes, this is, or no, it is not. Go ahead, take a minute, pause me, come back when you're ready. Yeah, the hair is real. Okay, so hopefully you just tried this problem Again, I just wanted to know, was this point a solution to this linear equation? So hopefully you just plugged in your x and y values. So the 5 is going to go in for your y. And then we have 2 times our x, which is 4. Sorry about that really bad handwriting. So then we get 5 equals 8 minus 3. So then we get 5, oh my goodness, 5 equals 5. 8 minus 3 is 5. So that checks out. That is a true statement. So then you should have ended by saying 4, 5 is a solution. All right, cool beans. So there's your answer. All right, in class, we're gonna break off, and if you're feeling good about it, you're going on to IP. If you were struggling, you were supposed to come with me to Pear Deck. Obviously, you're completing this or watching this now because you were in class. So I just have Pear Deck for you. But as always, if you're really struggling and you don't understand, just ask me for help, and I will gladly spend a few minutes with you doing some more problems for some extra help. So you have several questions, up to 10. I want you to do all of them, all 10 of these. If you do feel like this is too easy, feel free to start at question 7 and then try these challenge problems down here. This will bring you to Google Classroom, a Google Classroom assignment for Khan Academy, and your challenge problems are there. You do have your answer key in your folder as well. So where you grabbed your student packet for today, you see the answer key for the independent practice. So once you finish, please check your answers and see how you did. And then as a reminder, message me when you get this complete so I know to update your grade. All right, have a great day, and I'll talk to you soon.